All right, so let's look at problems like this where I'm going to be saying there's too much going on to even think about trying a basic comparison test. That's when the limit comparison test, when the limit comparison test is useful. Okay, so there's no way I'm going to start by taking little things off from the numerator and the denominator on this. Okay, what I'm going to do is I'm going to make up a new sum from the highest powers so that I can do limit comparison test with it, right? Because I have to have another sum that I know what it does to take the limit of for limit comparison test. All right, so let's make up my new sum. And with this new sum, there is no inequality going on, right? No inequality. I'm just making up a new sum. So from highest powers from the numerator, I get n squared. From the highest powers in the denominator, I get root n to the 7th. So this sum is n squared n to the 7 halves. So just fixing it up here. So I'm going to get n to the 3 halves, right? Canceling my n squared and n to the 7 halves. Okay, so I'm ready to do my limit comparison test. So my limit comparison test says I'm going to be taking the limit as n goes to infinity of my original guy. So I've got to write the whole thing down in its great glory. Times the reciprocal of the one that I know what it does. Oops, I forgot to say, what do I know this does? This converges by p-test, correct? Okay, so I'm going to be multiplying by n to the 3 halves over 1, right? Multiplying by the reciprocal. Okay, so now I'm taking the limit as n goes to infinity, so that means I'm taking the highest powers. So highest powers from the top and highest power bottom, right? So on the top I have n squared times n to the 3 halves. On the bottom I have the root n to the 7th. Wait a minute, that gives me 1, doesn't it? It's what happens a lot. So this is a number bigger than 0 and it's not infinity. So I get the conclusion they both do the same thing. Okay, so what did this one do? Oh yes, that one converged. So therefore, this one converges also by LCT. Good. Okay, so the big deal is that there's no inequality made between this one and this one, right? I'm just making up a new sum from the highest powers. Not taking a limit, I'm making a new sum, right? Because I forgot to put my summation things. All right. Again, too much going on for me to think about doing a basic comparison or taking off one number at a time. So I'm going to make up a new sum, not a limit, a new sum. Okay, so n equal 1 to infinity. So from the highest powers in the numerator, I'm going to take 2n squared. Highest power from the denominator, I'm going to take 4n cubed. Okay, so what does this do? Simplifying this, I get 4n squared over 4n cubed. That gives me 1 over n. So I know that this diverges by p-test. Okay, so now I'm ready to go do my limit comparison test. So my limit comparison test is limit as n goes to infinity, the original guy, multiply by the reciprocal of the one I know what it does, so multiply times n over 1. Taking highest powers, so highest powers from the numerator, highest powers from the denominator. I can take an extra step and multiply this out so you really clearly see it. This is 4n squared times n. This is 4n cubed. It's 1 again. Happens a lot. So this is bigger than 0, so they both do the same thing. So since this one diverged, I also get this diverges also by limit comparison test. All right, one more. Too much going on. Addition on top and bottom. I'm going to go right to making up a new sum. So my new sum, from the highest power in the numerator, e to the n is more powerful than n for n. So e to the n from the numerator. From the denominator, I have to bring both of these along because they're multiplied times each other. So the e to the n's cancel, so I get 1 over root n. This is diverges by p-test. So now I'm ready to go to do the limit comparison test. So limit as n goes to infinity. Write down the whole original problem. Multiply by the reciprocal of my new one. So root n over 1. Now remember, I'm doing highest powers when they're multiplied together, right? So in the numerator, this times this is the highest powered term, right? This times these two multiplied together would give me a smaller power. And on the denominator, there it is again, the same thing. So that's 1. They both do the same thing since this is bigger than 0. So I get that this one must diverge also by LCT.